all, thank you for joining this Farming and Water Scotland webinar supported by the Farm Advisory Service. My name is Alexander Pirie. I am an agricultural consultant based out of the Auchincruive office here in Ayrshire. And tonight I'm going to be joined by Mr. Adrian Jones and my colleague Seamus Murphy, who's going to be monitoring the chat for tonight. If at any point tonight anybody has any questions, this is just a descriptor for how to go about asking questions. Some of you will be familiar with how Zoom works and will know how to operate the chat and the Q&A functions. If any of you feel particularly strongly about speaking at any point, please raise your hand and we'll see if we can bring in some audio for you. But the purpose of tonight is really to tackle issues around slurry storage. We know that there are big changes coming to slurry legislation and slurry policy, particularly as Scottish Government try to get to grips with some upcoming green policy and climate policy. We know that there are big changes on the horizon. So tonight is really about making you guys aware of what capacity your farm requires, how to go about calculating that and evaluating that. And then also we'll talk a little bit about the Agri-Environment Climate Scheme. Obviously, that's back for a restricted round of funding this year. So we'll talk a little bit about the options that are available to you and whether or not you're eligible for that funding criteria. Now, as I said at the very beginning there, I'm joined tonight by Adrian Jones. Adrian is going to be up first for his presentation, so I will just let Adrian take it away.
Thank you, Alex. Okay, I'm Adrian Jones. I operate a company, A&M Jones Consulting, and we specialize in waste and water. I was previously working with the SAC as a consultant and again specializing in waste and water. I'm speaking tonight really on the subject of planning slurry storage in general, the items, the issues which are still asked when we get involved with work where a slurry store is proposed. I'm not going to restrict myself to lagoons, which is quite a common topic for us to be involved in. But nevertheless, we will talk about lagoons. It's more the general principles of planning and the general principles of deciding what sort of capacity we want and following that through even to what sort of size and type of storage might be suitable. There are obviously quite a few options, and the various options come at various costs, and the most expensive is not always the best. Nevertheless, we'll look at the options and we'll consider some of them tonight, hopefully. And as Alex has pointed out, if you have any questions, while you remember the topic, note it down and put it forward and we'll address that after the presentation. Okay, we start off with a slide of a steel internal ring store there, which will continue, I think, for a very long time, although we're seeing a lot of lagoons going in. Slurry stores, circular and square, still go in, and they go in for various reasons. We're maybe looking at a contentious issue at the bottom of that slide before we move on from my title slide, and that we're looking at a jetting nozzle. And we know that the legislation now being considered is about to remove high-level nozzles ejecting slurry at high pressure from tankers and spreading onto land. I'm not going to comment on any proposed legislation. The consultation document is available, and it's available for farmers to fill in until the 13th of April, I believe. But to me, this jetting nozzle we're looking at here could also be a point of contention. Okay, next slide, Alex, please. Thank you. You'll have realized now that I'm not entirely in control of the technology here. I still have a manual input by asking Alex to shift the slide for me. So the objective for increasing storage Really, the base of this is to allow effective and viable management, not only of slurry, but of buildings, of stock, and of land management. So allowing effective and viable management is really the main reason for considering slurry storage. If we've got slurry storage already, again, we need to be able to work within the legislation that we have now and have had since 1991, but also the slight revision of that legislation, which is now proposed. It's there, slurry storage, to enable good use of slurry nutrients. And it does this in two ways. It does it by allowing us to hold slurry until the quite significant nutrient value can be applied at the right time for a growing crop. And we now frequently and commonly are applying slurry to growing crops, even with umbilical systems. It's possible to run over arable crops. And of course, we run over grassland all the time with umbilicals. To use the nutrients as the crop uptake takes place, and to use the nutrients and apply the nutrients when weather conditions allow us to apply slurry in reasonable conditions where runoff will not occur, where leaching into drainage will not occur, and where the nutrients can be taken up. To reduce environmental risk, it goes together with using the slurry nutrients. If you're applying with a system storage and application in the right weather, on the right crop, at the right time, you not only use the nutrients, but you're reducing the environmental risk. And the compliance with the general binding rules. This is quite significant because the controlled activity regulations allow you voluntarily to spread slurry in certain conditions without strictly legislating. So compliance with GBRs and GBR 18, particularly, which is applicable to the application onto land of organic manures, is very important. And slurry storage allows us to do that and maintain a viable, environmentally friendly and a good nutrient utilization. The systems have got to be cost effective, they've got to be viable, and they've got to be robust. And they've got to fit. A system for one farmer is not necessarily the system for another farmer or farm. There's a fit about this. Some people like lagoons, some people like concrete stores. A concrete store today, circular, will cost you roughly the same price as a steel store, but some people have a preference, and that's what I mean by fit. Sometimes they're things that are hard to describe, but they're there with you. If you're buying the store, then you have a feeling about it, and it's got to fit your feeling. I said cost-effective, viable, and robust. The slide that we're looking at there shows a band spreader, very thin bands. These are 2-inch drop pipes over a 10-meter bout width, and going to 5 meters either side, up to 10 meters, allows a significant flow rate from the slurry store while maintaining a reasonable application rate. And the slurry that you're looking at there on those bands that was spread in the last dry spell a couple of weeks ago is going on at 25 cube a hectare over a 10-meter width boom. Next slide, please, Alex. Okay, we're thinking about putting a slurry store in. What have we got to think about apart from the fact that we might want one or need one? Information, sources, consultations, and authorisations is the heading of this slide. So information, first of all, there is the Scottish Agricultural Colleges, there's myself, there's many other people, and there's a lot of published information which can help you look at the type, how you determine size, etc. There are bodies that you have to consult, and there are bodies that you have to obtain consultation from. And I've put SEPA at the top of my list because they can both provide information, you can consult them, and they do authorize. So SEPA for me is fundamental in this. And I would always encourage an early and informal approach to SEPA if today you're considering spending what might be between 50 and 250,000 pounds easily on a farm. It is better to start off on the right route. If you're going to put the building up, make sure you put in a good foundation, and finding out the do's and don'ts at an early stage is a lot cheaper than finding them out later. So SEPA will look at and tell you standards. You need to notify SEPA in order to gain approval for use at a period when you've finished building, but before you use. And SEPA provide various pieces of information, and included and very useful in that information is up-to-date rainfall for sites all over Scotland. This is open data on the SEPA website, and there are rain monitoring stations quite frequently across Scotland. So I, for example, close to Ayr, frequently use the Dalbeattie one for the southwest. There's Monive, there's Stranraer, there's Newton Stewart. They're fairly close together, and they give me mean rainfall for the last 10 years, and they give you the last 12 months rainfall. So a good point of reference when you're looking at rainfall values, when you're considering the volume of water from any aprons or catchments such as silage clamps, middens, and landing on slurry storage. The planning authority is next. You have to go to planning for any development in storage, which is over 465 square meters. That is most lagoons, and it's some slurry stores. It's wise to apply to planning, even if you think you've got an exemption, and they will certainly tell you if you've got an exemption and you've then got it in writing. You always go to building standards. It is law and has been since 1991 that you go to building standards and apply for a building warrant. And that is associated with any storage tank, be it for slurry or silage effluent. And then the Scottish Government, not only associated with funding schemes, but also information and the funding that the Scottish Government do to people like SAC Consulting to provide information generally to the farming industry. Next slide, please. And all of these authorities, of course, have websites for reference and information. The general requirements for storage, and I'm talking about storage in general here. So I'm looking at slurry stores, I'm looking at slurry lagoons, and I'm looking at silage effluent tanks. These general requirements apply equally. So compliance with silage slurry fuel oil regs Scotland. These have been with us since '91. It's almost a quality standard for you when you pay for a piece of equipment which is going onto the ground, a slurry store or a lagoon or a silage effluent tank. It has to comply with this set of regulations. And this regulations includes reference to the second one down, BS 5502, which is the standard of construction and operation, in this case for slurry stores. So tanks supplied by various companies have to be to a standard, and they have to be installed to a standard. So when you pay your money, you expect to get it for that standard, and it's not a warranty as such, but it is a quality standard that helps you. Building control, building warrant, the last but one on the list there, just wants to see this built to BS 5502. That is where they are involved. They look at the drawings, they look at the design, they sometimes look at the build, and they decide whether it does comply with BS 5502 and the silage slurry fuel oil regs. And if it does, then you will get a warrant completion. And then, of course, planning permission, more so related perhaps to how it looks, where it sits, the impact on the general population and the countryside. But planning permission in every case is required. Not underground. If we're into a silage effluent tank or a slatted tank, then generally it's building control only and not planning permission that we require. Next slide, Alex, please. Okay, when and where? When? Time of year is important. It's important because of the weather. The ground surface water has a big influence. Access to the site has a big influence. If you're building a store or a lagoon, we've had a couple that started in November, early December this year, and they're still waiting to be built. Machinery went onto the site, it's come off the site, and it's not yet gone back on. Whether stock are in or out is an important question as to when you build. You have to really build these things when you don't have to put slurry in. It's handy when stock are not walking around the yard or up and down the access aprons that we're using to build the store and traffic. And the amount of slurry that you've got in storage and that you have to store. Where it is important. You require appropriate structural ground conditions. You've got ground and surface water issues, always groundwater, always surface water, and particularly important with slurry lagoons. How lagoons look, how tanks look, a visual aspect of this, something which planning will comment on. Odor and smell, proximity, for example, to neighbors, whether the store is on a windward or a leeward side, downwind. I don't want one really upwind of me, close to the end of my windows or garden. So consider the position of the store relative to you, your house, your asset value, where you live, and proximity to other people. And access and machine operations are always important to where this thing goes. Perhaps not so important with umbilicals and pump transfer, but very important if you're going to carry on using a tanker. We need many, many journeys backwards and forwards. Future developments don't restrict expansions to cubicle houses. We might want to extend an existing house by a bay or 2 bays, perhaps to install a parlor, put more cubicles on. If there's a slurry store been built 5 years ago, it's in the way, it's not going to be moved. And then finally, transfer in and out, again with access, distance to fields from umbilicals, location to field spreading areas from the store to the land application sites. And of course, the cost implications. Some sites are inherently more expensive than others. If I go too close to a building, if I go deep with a tank, these all add cost. Next slide, Alex, please. General requirements still, okay, the storage type, capacity, dimension, location, and levels. And what we're looking at there is a lagoon, very common. That's a high density polyethylene lined lagoon in North Ayrshire. It has a safety fence around it. It has a bank slope of 2-in-1. It's lined with HDPE, high density polyethylene, which is a similar material to that gas pipe and water pipe is made out of when you see it on the coil. It has 4 umbilical mixing points. You can see on the right-hand side of that slide, a black 6-inch HDPE pipe, which extends outside the fence. So we can couple an umbilical pump to that using lay flat. The HDPE pipe extends down the bank of the lagoon and ends up in the base of the lagoon, anchored again on a concrete block. And we can take slurry out of the outlet, the gravity outlet, the valved outlet, circulate it round and put it back in through that pipe, which in this case is 1 of 4, and use it to agitate the lagoon without putting a propeller type agitator in there. My feeling, my opinion is it is better to mix below the level of slurry rather than use tractor shaft power to throw slurry through a nozzle, pressurize it only to squirt it through the air. It takes management, but it works very successfully, and it's a more efficient way of mixing if we can use an umbilical pump. It's a very quick way of mixing if it's done properly. Next slide, Alex, please. Okay, this is the tank. It points out 3 things, this slide. It points out the fact that a cylindrical or a circular slurry tank, and we're looking at the section of that, you can see the base at the bottom. We've got an orange block, which represents the farm sources. So this is all the slurry, all the washed water, and all the contaminated rainfall. Then we've got rainfall landing on the store, which is the blue band. And then we've got 300 millimeters of freeboard over the top of the blue band. So the procedure is we calculate the farm sources, slurry, water, washings. That gives us the volume that is orange. We then decide what sort of store we're using, the dimensions as an example of it, and we look at how much rainfall goes onto it, the volume of rainfall. And then we add on the freeboard. And in the case of a tank, it's 300 mil. So this means if you look at the numbers on the right-hand side of that tank, we've got 2,000 cubic meters coming from the farm through a typical 6-month winter. In that 6-month winter on this site, at 0.8 meters of rainfall, 800 mil over the 6 months, we collect 400 cubic meters of rainfall, and the freeboard volume is 153 cubic meters. So when we add all of these together, we get the total volume of the store, 2562, just over 500,000 gallons for the 2,000 cube of slurry from the farm. Next slide. Thank you. The lagoon is slightly different. Next slide, please, Alex. Thank you. Same principle. The tank's at the top, the same 2,000 cube. The lagoon is at the bottom with a 2-to-1 bank angle. You'll see it too holds 2,000 cube. It too is 5 meters deep, as was the tank above it. This time, instead of having 400 cube of rainfall, I've got 866 cube of rainfall, because to hold the same volume in the orange block, I have a wider top area as the sides of the lagoon are angled outwards. I also have a bigger freeboard at the top because the legal freeboard requirement on the lagoon is 750 millimeters. So all in all, I have quite a big difference in the total internal volume. For the same 2,000 cube from the farm, the total volume of the lagoon is 3,800, whereas the tank was only 2,500. The tank is more expensive per cubic meter to hold, but it requires less total volume. The lagoon normally comes out cheaper, but it is still always worth at this stage, costing nothing at all, to look at both options before you decide on one or the other. Both, in my opinion, are perfectly serviceable. The lagoon is usually cheaper, but the tank often fits where a lagoon won't fit. Next slide, please. Thank you. Consider both ends of the system. And by both ends, I mean, we're looking at capacity to start with before we look at type. So we're looking at the source, which is the top slide, sources to be collected, how much, how long do we need to store it, why are we collecting it and storing it, and are we minimizing water ingress? And then the bottom slide is, what are we going to do with it? We're going to apply it to land, utilize the nutrients. We've got to consider the area that's available to us, the conditions, the cropping, when, and at what application rate. And somewhere in the middle of the top slide and the bottom slide is the store. But we need to look at both the front end and the back end of that occasion. Next slide, please. Other actions, very, very important. You're going for storage. We're not going to store water for no reason at all. It costs us to store, often costs us collect, often costs us to spread. £1.50 to £2.50 a cube. If it's slurry, that's bad enough. If it's water, it's a waste of money and a waste of time. So very quickly, other actions here, basically for me, always prioritize water segregation from slurry and dirty water. So improve systems for exclusion of clean surface and roof water. Make sure drop pipes work and gutters work. And I know you've heard that before, but it's very, very important. Make sure that things like roadways, access roads, main roads are not draining towards the system, which are then going to be collected and stored. Part B, ensure that having bought the slurry store, we are going to intercept all the slurry, everything dirty, and collect all the slurry and drainage and be able to transfer it into the store. And the bottom part of the slide simply states examples of where we might be able to reduce volume. Access routes for stock and vehicles. If we change the way stock move around the steading, change the way vehicles move or the type, the way we feed, feeding arrangements to prevent the spread of contamination by stock. If we put a bunker inside a building where stock is standing, every time we fill the bunker and come out again, we're going to fetch slurry out with us on the wheels. Protecting feed areas, troughs, barriers from rainfall, and avoid spillages and leakages. Next slide, please, Alex. Just carry on. Next slide, please, Alex. We'll skip that one. Okay, very, very quickly. What do? We do an audit. Top left, top right. Top left at the top. Steading and operational appraisal audit. Determine the volume of whole slurry produced from stock. I've just given you two examples, 150 dairy cows, what they produce per day, and in total, the daily production of 7.95 cube. I've also included 30 young stock. There were a lot more on this farm. I put 2 in to do a simple calculation there. I've added it up to know that I get 9 cube of slurry per day from these stock, 2,000 gallons a day. If I'm going to store for 6 months, and that's not necessarily the case, it might be slightly less and it might be more, depending upon my management system. Multiply it by 6 months as an example, and I'm getting 1,600 cube of slurry, 362,000 gallons. And remember to add volumes for bedding. Sand particularly adds quite a lot of volume. You take some sand out before you put it in the slurry store, but nevertheless, a cow place will lose between 5 to 10 kilograms a day of sand into a passageway. Next slide, please. Wash water's taken into account. You can use a PEPFAR code figure. In here is 30 litres per day times my 150 cows. That's 810 cube in the 6 months. And these figures are available in the Code of Good Agricultural Practice, the Prevention of Environmental Pollution from Agricultural Activity. The PEPFAR code has been with us since '91. It's better to use measured values, the statement at the bottom of the slide. If you can measure how much you use in a day's milking, measure it every day for a week, even estimate it for a week. It's a better figure to use than a standard figure. These figures can be way out sometimes for some farms. Next slide, please, Alex. Finally, rainfall, contaminated by aprons, dirty aprons. So here I've got a dry cow feed apron, gives me 72 square meters, 18 by 4. And I've got a cubicle house apron, gives me 300 square meters. If I multiply the same rainfall onto those areas as I did in my tank and lagoon slide, I've actually got 1.7 cube a day there, 1.674. In 6 months, that's 300 cube of water off those aprons. Next slide, please. Segregation, very, very important. I'm going to whip through these very quickly because you've seen them all, I'm sure. Very, very difficult to segregate the yard area on the right from the slatted storage channel right in front of us on that slide. In fact, all the water from the right-hand side of the gates, whether it's got cattle on or not, drains downhill and into the slatted channel 365 days a year. So that is an area along the gate line that we would be looking for some change if we were going to try to size a slurry store for this site. We would try to segregate the two areas. So our store would be smaller, our application costs would be less, and our nutrient would be not diluted as much by rainfall. Next slide, Alex. Same principles here. Slightly different in that what we've got is its drainage segregation along a feed barrier, which has a decent overhang, but as good as no overhang at all if the rain is coming in horizontal from the right-hand side. So the overhangs, short overhangs like this, which are typical with our buildings in Scotland today, questionable as to how much benefit you're getting there, both in keeping feed dry and certainly preventing rainfall landing on the feed, and then, as in this case, running off onto the access road, out at the far end onto a main road. Next slide, please. Farm access track, that draining downhill, a reasonable attempt, but it should have been deeper and wider of stopping that water entering the collecting area, which is below us. Next slide, please. These are all segregation, okay? Drop pipes. We've talked about keeping water out of slurry, but we need to keep slurry out of water. There's a grid at the bottom of a drop pipe. Next slide. And finally, on the lagoons and segregation, this is a lagoon that's been built within the last couple of months, bears no resemblance to the drawing at all. And if you look at the surround of that lagoon, it falls towards the liner. So the rainfall on the lagoon is not only the rainfall on the lagoon, but the rainfall from about 15 meters to our left-hand side, more or less halfway around the lagoon, collecting nearly double the rainfall that it would have collected had the fall been the other way, away from the liner. Next slide, please. Next slide. We'll just carry on with this. Just keep going through. I'm very conscious of time, Alex. These are segregation examples, clamp fronts, no division there between what is effluent and what is clean water, which is where I was standing when I took the photograph. The whole lot falls together into the stream you see at the bottom of the slide. So we're collecting a lot of water into the effluent system, which inevitably is going to go to slurry storage. Next slide, please. Next slide, please. Okay, very quickly, this is a concrete clamp, left-hand part of that drawing. I'm looking at a clamp from above. So I'm sitting right above it, looking down at a plan view. On the right-hand drawing, I'm standing at the front, looking into the clamp. So it's a concrete walled clamp, in this case, rectangular, typical area 15 by 30 meters. You can see the black line as the walls, and outside the walls at the bottom, as per silage slurry fuel oil regs, I've got a perimeter channel to collect effluent that may or may not seep through the walls and the wall joints. When I do a calculation on the catchment, I have to include these peripheral drain. The difference here is very small if I'm looking at the volume going into a slurry store. If the floor area only is 620 square meters there, the whole catchment area to the outside of the drain is 730 meters square. So I've added about 100 square meters, which adds about 80 cubic meters of water through a 6-month period. 80 cube is 8 tanker loads. Next slide, please. Different for an earth bank clamp. Look at this one, typical earth bank clamp. This has the same floor area as the last clamp, which was a concrete walled clamp, effectively the area of the floor. Some people calculate the catchment as the floor area. If you do that in the course of calculating the catchment to propose a new slurry store, you are cheating yourselves instead of the storage period you're going to get. If you look at what comes off the clamp floor here, top calculation, 500 cubic meters of water. Look at the bottom calculation. If I go to the middle of the banks, which is where water usually comes from when it rains on an earth bank clamp, it's 1,000 cubic meters, double the catchment area. So if you think you're putting in a 6-month store, but you've only measured the clamp floor, you'll be disappointed. You'll only get 5 months and 1 week instead of 6 months. And if you do that over 3 clamps, your 6-month store ends up somewhere down about 4.5 months store. Next slide, please. Next slide, please. I am conscious that time is racing on, Alex, so I'm going to race on a little bit. Next slide, please. Okay, this is quite significant to look at the bottom line here. What we've done here is we went through that audit on the last slide, and from that farm, I needed to hold 3,800 cubes, sorry. You look at the 2 numbers in the bottom right of the slide. Okay, I needed to hold 3,800 cube, but I have a slurry store on this farm that already holds effectively 1,800 cube. So my new store needs to be 2,000 cube to make up the difference. Next slide, please. Now I'm following this through quite simply using a circular tank. Top figure in the slide, right-hand side, farm source capacity required, 2,000 cube, 440,000 gallons. If I add the rainfall and I add the freeboard onto that 2,000, on the tank size I've put near the 5.5 diameter, 5 meter deep. The overall volume of the tank is 2,560 cube. Okay, over 500,000 gallons to hold the 440,000 gallons we needed at the top. Go to the next slide, please, Alex. This is a comparison using a lagoon instead of the tank. I've still got the same 2,000 cube on the top line coming from the farm. On the bottom line now, total internal volume of the lagoon, instead of being 2,400, as was the tank, this is 3,800 because the lagoon is of a bigger area, more rainfall, bigger freeboard. So we need a bigger internal volume. And it's the internal volume that will govern the cost of the structure. A slurry store today, circular, is costing you around about 32 to 35 pound a cube. A lagoon is costing you around about 15 pound a cube on the total volume. So I've got to work out the 2 volumes here, the 2.4 for the tank, the 3.8 for the lagoon, and multiply it by the corresponding cost before I know what the real price of storage is in a tank and the real price in the lagoon. Next slide, please. Alex, next slide, please. Thank you. There's the comparison. The same tank, back one, please. Nearly finished. Back one slide, Alex, please. That's it. So we've got the 2. Back one slide. No, forward now. Forward 1. Keep going towards the end. There we are. We come back. No, you've gone too far. There's a lot to be said for manual control, you know. Can you go back 1, please? That's it. Can you stop there? Okay. So we've got the same orange volume. It's gone again. Not to worry. Same volume in orange for the tank and for the lagoon. Look at the size of the lagoon compared with the tank. The 2,500 for the tank 3,800 for the lagoon, and look at the physical size of it on the ground. Okay, that's the difference. They're both the same depth, both 5 meters deep in that slide, both holding 2,000 cube from the farm, but the lagoon is wider for the same depth and it collects more rainfall. It collects twice the rainfall. So consider one against the other before you buy. Final slide, please, Alex. And there we are. So good planning helps achieve a cost-effective and viable system, I hope. And the main objective for me, and the main driver for me when I think of doing these jobs, whether it be collection, anything to do with buildings, slurry collection, water segregation, whether it be to do with slurry storage, and whether it be to do with land application, it's always to try and create a minimal solution, not go over the top, but a minimal but appropriate and viable and robust system. And to utilize as the main objective with slurry, the nutrient as effectively as you can. And use that value in the nutrient to offset the costs of storing and handling the slurry. It won't equal it. You will still pay out more than you will get back, but it's worth using the NP and K because it can contribute a significant amount towards the cost. Thank you.
Brilliant. Thanks very much, Adrian. That was really good. Sorry, I think we maybe had a bit of a delay there, Adrian, just as I was moving the slides back, but we got there in the end.
Okay. Maureen, can you come in here? Your phone has just gone off.
So, my role here tonight, folks, as I said at the beginning, my name's Alec Pirie. I'm an agricultural consultant based here at AIR, and it'll be no secret to a lot of people listening here tonight that the Agri-Environment Climate Scheme is back for another round of funding. Now, some of you may be familiar with the Agri-Environment Climate Scheme. Some of you may have been involved in it in the past. Some of you may even have existing contracts, and dare I say it, some of you might have had me work on your contract. But the purpose of tonight is really just to make you aware of the slurry funding that's available as part of the scheme, and to give you a kind of idea of what levels of support are available. So just an overview of the Agri-Environment Climate Scheme for those who may be unfamiliar with it. The Agri-Environment Climate Scheme is Scotland's leading environmental and climate scheme. It was developed partly to protect Scotland's water environment. That's one of the key components to it. There are 4 main funding pillars, as I like to think about it, and the bulk of environmental planning will fall into the environmental land-based outcomes options. But you'll see that there are also provisions there for slurry storage, support for organic farming, whether that's conversion or maintenance, and this year, support for public access is back. It was removed back in 2019, so it's good to see that come back, and that's potentially an indication of where Scottish Government want to see funding go in the future. The funding that's available for slurry storage under AECS is intended to bring farms up to 180 days effective storage capacity, and I know Adrian will have covered a lot of the groundwork for what I'm going to talk about here, but the aim is to help improve the water environment. We know that Scotland has a variety of very important protected water courses and water features. So any way that we can limit or mitigate the entry of slurry into those water courses, and as Adrian said, reduce the amount of dirty water that's also entering that environment is ultimately beneficial. And it's no secret that climate change is a really big issue right now, and it remains to be seen how policy is going to develop in the future. But we know that by controlling the amount of slurry that was being produced on farms, and by managing that correctly, we can maximize the value of our slurry while minimizing the potential emissions. Okay, so if you're interested in going for the slurry AECS funding, these are the things that you really need to know. number one, the option is no longer available for areas that are in designated nitrate vulnerable zones, or NVZs. Now that might be disappointing to some people who are on tonight, and I can appreciate that. But we want to really target priority catchments, and we'll talk about that in the very next slide there. The option must not be used to increase slurry storage capacity to accommodate an increase in livestock numbers. And again, I can appreciate that that's disappointing for some people, but the grant must not be used to facilitate an expansion. It's about creating responsible slurry management for what's currently on the ground. Obviously, it'll sound really straightforward here, but the purpose of it is for livestock systems that are based on a slurry system. And crucially, if you want to go for the funding round, you must not have received slurry storage funding in the previous round of the SRDP. Okay, now I appreciate this map is a little difficult to see here, but for those who are considering slurry storage and want to know about their eligibility, this map highlights the areas where you could be considered eligible for slurry storage. Your eligibility for slurry storage, as well as all of the other options available under AECS, can be found on the Rural Payments online website. And you'll see here that the link that I've got on this particular slide will take you to the spatial targeting tool. And what that will do is it will allow you to search your main location code to assess which options are available to you for this particular funding round. It is important to note that there are some options that previously were supported that would have that were specifically designed to benefit the water environment. And they are not available within this restricted funding round, unfortunately. But crucially, slurry storage is. So when we're putting together an application for slurry storage and an AECS, there is the online application process, which your agent can complete. However, before we get to that stage, it's absolutely crucial that we have a farm waste management plan. By completing this farm waste management plan, we'll be able to carry out an audit for the slurry and dung, the effluent and the dirty water produced on farm, and by doing so, get a grip on how much storage capacity you require for the number of stock that you currently have and the size of store that's going to be required to bring you up to that 180 days capacity. The Steading map, really important, one of the aspects of it, the Steading assessment should be carried out with an associated map showing areas of dirty and clean water on the Steading, and we'll see that in just a second. Also, it's really important that we get to see a risk assessment map for manures and slurry, a RAMS map, and we'll get to see an example of that in the next slide. Okey-doke. So these are just a set of the management requirements that are currently applicable to anybody who is considering going for slurry storage within this restricted funding round. I appreciate there's a lot here, but I would encourage you to take time to go through the Rural Payments online and make sure that you meet the criteria and can meet the management requirements where applicable to your business. Now, I mentioned Steading maps and RAMS maps. These are just two very basic examples of what we would be looking to see when we're putting together a farm waste management plan. You can see here in the examples highlighted, we have areas of dirty water, areas of clean water. We have very clearly identified the different buildings on the map, as well as the proposed new storage. And then equally as important is that we undertake an assessment of the suitability of the fields that you have on the farm for spreading. Again, this is something that Adrian touched on at the very beginning, but really important that we understand which fields can take more slurry and in which conditions it's suitable to apply them. And also areas where spreading is totally inappropriate, obviously that will be around the farmed water environment. Okay, so in terms of funding support, I have the figures there on the slide here. You can see that there's £15 per cubic metre of capacity created through the scheme. And that goes up to a maximum of 2,000 cubic metres of storage. That is regardless of whether it is a tower or a lagoon. But you can see the supporting capital items there as well. So there are further incentives to the storage, and you're not going to be left high and dry once you've got the tower. There is that additional support there. And for anybody interested in applying, just be aware that the current deadline for the 2021 funding round is currently the 30th of June. This is a similar deadline to what it has been in previous years, but what I would say for people who are interested in applying is that in previous years, the environmental funding round in particular typically would end round about now, the 31st of March, the middle of April. So for those who are considering going for slurry storage, be aware that if you're approaching a consultant or an agent to have this work completed, you will be competing for their time in terms of their ability to complete environmental plans that do not include slurry. So my advice to you on that would be, if you are interested in applying for slurry storage, that you get ahead of the game and you make that known as soon as possible. And appreciate that we are right in the middle of IACS. A lot of you guys will have submitted your IACS or will have appointments to submit your IACS. We are in a very busy period of time, but this is really, really crucial, and where possible, you should get ahead of the game. Okie doke. So by comparison, this is quite a short presentation, and I don't want to take up a huge amount of time. But I think, Adrian, if you could just come back now, we'll maybe go straight to Q&A session.
Yeah, we got some good questions in there during both the presentations.
Fantastic.
I'll kick off now. I think, yeah, there's Adrian unmuted. So there was a couple of questions about covering slurry stores. We'll start with one about floating covers, and if you have a floating cover, can you then exclude the rainfall in your storage calculation?
Can you hear me? First of all, yes,
Yep.
yes. So this is live, I take it. Okay, well, floating covers are an issue for me, and I think they should be an issue for anybody that is listening at the moment, because we are being asked to consider covering now, as IPPC farms have been asked a long time ago to cover and prevent ammonia emissions, primarily, not addition of rainfall, but ammonia emissions, particularly from storage. And this is applied up and down the east coast of the UK to pig farms, for example. Now, covering a lagoon with a floating cover, the idea is that the cover that is borne by the liquid in the lagoon, be it water or be it slurry, and they take various forms. They can be like a sheet of bubble wrap, to simplify it, or they can be a sheet of material very similar or the same as a modern lagoon liner, which either sits and floats on top of the slurry or the water by the fact that it is caught there, it cannot sink, it floats, or it is suspended on the top of the slurry or water in the lagoon by a series of flotation devices. And these vary. They can be square, round pipes, all sorts of things have been tried. Full covers are tried, segmented covers are tried. I've been involved with a number of companies now that openly advertise these and attempt to promote them, and there is now a need for them. But the practical difficulties involved in putting a floating cover on a lagoon and working it while you are mixing slurry in a lagoon is extremely impractical, very, very difficult to manage. Some of these floating covers, going back to the original question, are made in such a way that the rain is caught in segmented sections. And the segmented sections can be drained to a single pumped well, one of the sections. And therefore the rainfall can be pumped out theoretically. So you should be able to neglect the rainfall on the lagoon, providing the lagoon cover is working 100%. I have yet to see a floating lagoon cover in an agricultural situation that works 100% or even 50%. I recently had an experience where I had two farmers wishing to purchase a cover of their own. They volunteered, they wanted to do it. They were prepared to do it. The companies they were going to go to eventually, before the check was signed, decided they didn't want to sell them. And they didn't want to sell them because they were afraid of the problems that were going to arise once they saw what you did with slurry in a lagoon. So we have a way to go with this as far as floating covers is concerned. Not saying it's impossible. What I'm saying is at a achievable price, a price that you would expect to be able to be afforded to go along with a lagoon, I have not seen a good practical answer, and neither has one of my clients who's actually been around to look at some.
Okay, so
Okay.
Proceed with caution anyway.
Yes, quite effective ways of achieving ammonia reduction, as is the most parts in the IPPC farm situation, where they put on a floating aggregate, which forms a floating particulate barrier, if you like, across the top of the liquid in the lagoon. And this depresses ammonia emissions quite significantly and is fully allowed and supported at the moment throughout the UK in IPPC situations. Materials like LITAG, pumice, there's various other materials that are used. But while it keeps ammonia in or depresses ammonia emissions, it does not keep rainfall out. You can go in there, you can mix the slurry with a prop mixer or an umbilical, and the particles simply come back up to the surface and reform a particulate blanket. So practically it works for depressing ammonia relief, but it does not work to keep rainfall out.
Okay.
Finally, one-liner, circular slurry stores, no problem. It costs money, but there are various cover options on a circular slurry storage tank. And I have seen significant square tanks which have actually had a portal roof constructed over them.
And is there issues with mixing in those tanks?
No.
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 There's another question then just came in while you were answering that. The covered lagoons, one attendee heard that they didn't need to be mixed as a material did not separate.
I don't believe it.
Okay. I think that answers all the questions we've had on the covering slurry stores, lagoons and tanks. The next,
just to add to that one, okay, we are presently involved with a client who is trying to get a settled sludge out of an anaerobic digester, and it has a covered tank, and digestion is supposed to reduce settlement. So that is an example.
Yeah. So like you said, we probably have some way to go before we can be confident in that.
That is my opinion.
Another question came in then with regard to increase in rainfall and climate change, and should we maybe be considering a larger freeboard on slurry stores with looking to the future? I don't know if Adrian or Alex either want to pick up.
Right. Well, really coming back to my freeboard is freeboard. So in my opinion, whatever you design in terms of capacity, freeboard is free. It's there basically in a lagoon to take windage. If you get a wind force 3, 4, 5 gale blowing across a lagoon, you get a wave on a 30, 50 meter lagoon. Some of our lagoons are 150 meters long. The wave height at the far end is significant, and without the freeboard, it would come over the edge. A similar thing happens on circular tanks that have a 300 mil freeboard. People automatically, I think, assume the freeboard is to give you a bit of margin. It is not, in my opinion, and it was not originally proposed that way in '91 when I was involved in the writing of the silage slurry fuel oil regs. It was there as freeboard, and it's there basically to avoid spillage and lapping over the sides when the wind blows. If we're designing for increased rainfall, we should build that into the rainfall, the blue strip that I had my drawings. And this year, for example, when I've looked at the 10-year mean on the SEPA websites, and I've looked at the 19 to 20 rainfall, I've used the 1920 rainfall, the last year's last 12 months, to give me a contingency over the last 10-year mean. And I state that it's not a hidden thing. The question is right to ask. And the person who's buying the store needs to ask that question. What contingency am I building in? A better contingency for me is that the slurry store is part of a farmsteading development. And ahead of the slurry store, next year or in 5 years, there is an area which has been taken into account here that is not roofed, that is collecting rainfall, that I will eventually roof. I might be feeding cattle on it. I might be keeping silage in it. It might be a midden or a handling area. But I would regard that as being my contingency rather than playing about with the dimensions of a tank or adding fictional rainfall.
Okay. One question then on air bubbler systems for mixing slurry. What are your views on that?
Yes, they work. I've got a number of clients here, particularly in Ireland, very, very popular still in Northern Ireland, and they work, in my opinion, very well. They've been shown, if they're operated correctly, to reduce ammonia emissions, but bubbler systems only work if they're running basically 20 hours out of 24 hours a day. You do not turn them off and then come back to work them again. While I worked for the Scottish Agricultural College, we tried 4 bubbler systems in various tanks, circular tanks and rectangular tanks. We couldn't work any of them successfully unless we kept them going. If you stop them, they block. And although they're manifolded, so that you build up pressure in one manifolded section, which is the plan, to blow the slurry particles away from the nozzles or the outlets or the permeable pipe or whatever it is, in practice, it does not work. If you let this thing stop for any length of time, and I mean a time period of maybe 1 day, then it will not all start up again. But they do work if you accept the fact they're going to run continuously.
Okay. Conscious of time now, so I'll just finish up with a few more questions, but I'll just finish up with this one finally. We'll going back to the covered lagoons. We have a question in about separated liquid storage with an undercover pipe mixing should be okay with a cover. Have you seen anything like that working?
Yes. Yeah. It's not something I've done in agriculture myself, but I have done it in veg processing and veg processed water storage. There's a bit of a problem in that some slurries will, if you we can't interact here, can we? So if this is mechanically separated, for example, when a mechanical separator for a farm, by the nature of the way it works, takes out the fiber. When you take out the fiber from a standard normal slurry, the small, heavy, dense particles tend to settle quicker, like a pig slurry does naturally. Take a pig slurry and it will settle hard. And then you can't mix properly with pipes. So sometimes if you mechanically separate slurry, you find that you then go in there and mix it, and what you're doing is mixing a layer higher than a very heavy, dense, settled solid. If you can't get in to move the solid, you lose capacity in the store. If you've got a lined lagoon with no concrete base, you can't get in to move the solid safely without damaging the liner. And you get into the same problems that most people will get into with sand bedding.
Okay. I think that answers that question. It is mechanically separated. Just got a comment back.
Yeah, it's a mechanical separated slurry still settles, but it settles in a different way. You only separate out what won't go through a screen. You're using a 1/2 mil screen in a mechanical separator on the basis that you take everything out that's bigger than 1.5 mil. So what you're leaving in are the really small, hard, dense particles, concrete dust, sand dust. And that's the stuff that sets like concrete in the bottom.
Mm-hmm.
And if you use lime in your cubicles, it will be concrete and it does set.
Okay, we've a couple more questions, but I think we'll try and maybe deal with these through a podcast that we're going to do afterwards, or maybe even get to them next week. We've got another webinar on next week, so I think we'll leave it at that, Alex, and I'll hand back over to you.
I see there's a couple of EECS questions there. I think in the interest of time, what I'll do is I will maybe try and reach out to you individually following this meeting and see if we can take your queries forward. So apologies if your question hasn't been answered here tonight, but we will come back to you. Just before we close off here tonight, folks, I just wanted to remind you, and Adrian did a great job of mentioning it at the very beginning, but there is the ongoing consultation for Slurry, and I would encourage anybody who is interested in having their say and seeing what the proposals are that could be coming down the line, that they check out the consultation, and again the links provided there. You should be able to get your responses in by the 13th of April. So we may even promote this again next week, just as a final reminder. Now, Seamus did suggest there that there are going to be more meetings coming up. So thank you very much to Adrian for joining us tonight. But next week we have our own soil specialist, Mr. Bill Crooks, and Mr. Hugh McClement are going to be joining us for a discussion on the nutrient value of slurry, the soil and slurry relationship, and the approach to slurry management in and outside of NVZs. So we hope that you'll join us for that, and please do feel free to get in touch with Farming and Water Scotland and the Farm Advisory Service. We have a range of great materials out there for anybody who has any interest in slurry management. All right, we thank you for joining us, and we hope that you can take something away from tonight. Thanks again, Adrian, for joining us tonight, and thanks to Seamus for moderating, and wish you the very best.